Hey guys, today we're going to take our notes about combining functions. So this is going to be on slide 20-22 in your digital notebook today. At the top of your paper, you can go ahead and put your title. These are notes 4B.2.3 combining functions. First, we're going to talk about function operations, which isn't new. It's actually from Integrated Math 1. But the functions that you looked in Math 1 were only polynomials. Now we'll look at log functions, rational functions, radical functions, different ones. So there's two different kind of notations that you could possibly see. So one possible notation that you'll see is you'll see parentheses, and inside it'll say f minus g, and then it'll have parentheses on the outside with x. All that means is that you're going to add f of x plus g of x. So whatever your function is for f of x, you'll just go ahead and add that function with g of x. That should be a plus sign, I apologize. And then if you see f minus g, then that means you subtract. You do have to pay attention to order because that's minus g. And you could see f with a multiplication symbol in between. That just means you're going to multiply the two together. Or you could see a division symbol, and this one you also have to pay attention to the order. So f of x divided by g of x. Okay, so there is kind of one new one that you haven't seen before, function composition. We actually have looked at it when we did inverses. We talked about function composition, that when you compose two inverse functions together, you're just left with x. But how you could see it written is you could see f, and then it's like a circle. It's not a multiplication. It kind of looks like fog of x. Or you could see it written as f of g of x like this. Either way, it means the same thing. You're going to plug g of x into f of x for x. And then just simplify as much as you can. So we're going to do a couple of examples not in the book, and then some examples from the book. So the first one, examples, you can write if f of x equals log base 3 of x to the fifth and g of x equals log base 3 of 2x, find f plus g of x. So what we're going to be doing is adding our two functions together. So we draw f and then a plus sign, and then we draw g. Okay, so f is this function right here. And g is this function right here. And we're going to add them together. So we're going to have log base 3 of x to the fifth plus log base 3 of 2x. So here we need to remember our exponent, or our log rules, log properties, is that if you're adding two log bases that are the same, they're both log base 3, that means you're going to multiply your pieces right here, x to the fifth and 2x. So to condense them, you keep your log base 3, but now you're going to multiply x to the fifth times 2x. You don't actually leave it like that though. You're going to have log base 3 of 2 times x to the, or 2 times 1 is just 2, and then x times x to the fifth, you add your exponents, so it's 2x to the sixth. You could put parentheses around it, or no parentheses, because there's nothing being added or subtracted after. All right, our next one is if f of x equals x squared plus 2x and g of x equals 3x minus 5, find f composition of g, right? So we're going to compose them together. So what it means is you're going to take g and plug it into f. So something that kind of helps me is I take g and I circle it. And what I do is I say, okay, this g is getting plugged into not just this x, but also this x in our function. So instead of x squared, I'm going to plug in 3x minus 5 squared. Instead of plus 2x, I'm going to have plus 2 times, instead of x, it's 3x minus 5. And then we can just go ahead and simplify to solve. So this, you can't just distribute the square because these two are holding hands. This means 3x minus 5, squared means 3x minus 5 times 3x minus 5. So we do a little box method. So 3x minus 5, 3x minus 5, and we would just multiply them together. 3 times 3 is 9, x times x is x squared. 3x times negative 5 is negative 15x. 3x times negative 5 is another 15x. Negative 5 times negative 5 is positive 25. So this piece right here is going to be 9x squared. Negative 15x, negative 15x, we combine those to get negative 30x plus 25. And then here we can just distribute. We don't have to do a box method or anything, so we get plus 6x minus 10. We're going to combine like terms for our final answer, so we have 9x squared. There's no other x squareds to combine. There's a negative 30x and a positive 6x. When you add those, you get negative 24x. And then we can combine our 25 and our negative 10 to give us 15. And that's our answer. So we composed them together. We took one and plugged it into the other. So we took g and we plugged it in for both of these x's. The squared and the 2 still stayed there. We just plugged in x. We composed it with the g, 3x minus 5. All right, now we're going to grab our workbook. So this is going to be one picture that we take for our digital notebook. And then this is in the workbook 4B that we've been working on. This is on page 61, I believe. Yeah, okay. So it says find f plus g of x if f of x is equal to x divided by x minus 1 and g of x is equal to x minus 1 over x plus 2. Determine the domains over which f of x and g of x and f plus g of x are defined. So these are rational expressions. We learned these in Math 3 first semester. So we want f plus g. So we're going to take our function of f and our function for g, and we're going to add them together. Okay, so it's x over, I'm going to put that in parentheses, the denominator x minus 1, because they're holding hands, they go together, and then plus, and then on the top I have x minus 1 times x plus 2. Okay, so if we think back to first semester, in order to add fractions, you have to have common denominators. So right now our denominators are not the same. Since they are binomials, those pieces go together. You can't break them apart. So you just take the second denominator and multiply it on the first fraction. And then you take the first denominator and you multiply it on the second fraction. So on top, we have x times x plus 2. So I distribute. I get x squared plus 2x over the denominators. You don't actually have to multiply out. You can. You don't actually have to multiply them out though. Plus, and then on top over here, we have an x minus 1 times x minus 1. So you'd have to do a little box method for that. When you do your box method, you end up with x squared minus 2x plus 1. And on the bottom, you don't actually have to multiply them out. You could. Now I have the same denominators. So we notice that our denominators are exactly the same, x plus 1 or x plus minus 1 times x plus 2. So when you have the same denominator, you keep that denominator the same. And you combine like terms in the numerators. So x squared with x squared becomes 2x squared. My negative 2x and my positive 2x are going to cancel each other out, so then I just have plus 1. So from here, the reason why I left these ones factored and I didn't multiply them out is you can try to see if you can cancel anything that's the same on the top and the bottom. Unfortunately, the top, there's nothing, there's no GCF, nothing that can be factored, so that is just our answer. We'll have to leave it like that. And then the other thing that our problem asked us to do was about the domain. So domain are your x values. This is basically just saying if there's any restrictions, excluded values or anything. So what you do is you look at your denominator. So whenever it's a fraction, remember your denominators cannot be equal to 0. So my first, it says determine the domain of f of x. Well, you look at your denominator, x minus 1, you basically just set it equal to 0 and say x can't be that. So x cannot be equal to 1. And then for domain of g of x, you look at your denominator, it says x plus 2, you set that equal to 0 and just say x cannot be equal to that. So x cannot be equal to negative 2. So when it says determine the domain of the combined function, it's just both of those. X can't be equal to 1, x can't be equal to negative 2. So that's the domain for this right here. Just the excluded values, basically. We did that when we did rational expressions. All right, go ahead and flip your paper over to 62. Our next one says find f times g. Okay, so we're going to multiply them together. F of x is the square root of x minus 3. G of x is the square root of 4 minus x. And we want to determine the domains. Okay, so we're going to take these two functions right here, and we're going to multiply them together. So we're going to take the square root of x minus 3 and multiply it by the square root of 4 minus x. So to go ahead and do that, we're going to use this little property over here. We have a little radical property that if you're multiplying two things together, as long as they're both square roots or both cube roots or both whatever, you can just multiply them together underneath the same radical. It goes both ways. You can take two things that are being multiplied and split them up into two separate radicals as well. So we're just going to go ahead and multiply them together underneath the same radical. X minus 3 times 4 minus x. We can go ahead and use a little box method to multiply these out. So we have x minus 3 and 4 minus x. I get 4x, negative 12, negative x squared, and positive 3x. So underneath my radical, I get negative x squared plus 7x minus 12. It did ask us to determine the restricted domains. So remember, for your restricted domains, with the rational expressions, you couldn't have 0 in the denominator. With a radical, remember, with a radical, you can't have a negative in the underneath the radical, right? You can't have a negative under the radical. So what we do is we just take our pieces, okay, our x minus 3, and we say that it has to be greater than or equal to 0, and then we take our 4 minus x and say it has to be greater than or equal to 0, and then we solve. So we add 3 to both sides, so x has to be greater than or equal to 3. Over here I'm going to subtract 4 on both sides. I get negative x is greater than or equal to negative 4, but when you divide both sides by negative 1, you have to flip the sign, so it becomes x is less than or equal to positive 4. So x has to be greater than 3 and less than 4. Well, that doesn't give you very many options, right? So x has to be less than 4, but greater than 3. That's our domain. One last example, it says find the domain, or no, find the function that results from the composition. So this is that composition of functions right here. If f of x is x squared and g of x is 2 minus x. I'm going to move this up just a little bit. Okay. So for our problem, we are doing composition of functions. G comes second, so G is going to F. You got to pay attention to that. So I circle G, and I'm like, G is going into F, where the X used to be. So it's X squared, but instead of X, we're plugging in the square root of 2 minus X. But the squared still stays there. So instead of X, we're plugging in the square root of 2 minus X. Well, when you square and square root something at the same time, they cancel each other out. So now we're just left with 2 minus x. And that's just our answer. We do have to describe our domains. So our domain here, you can plug in any number, positive, negative, whatever you want for x. But here, you can't have a negative under your radical. So we're just going to go ahead and say that 2 minus x has to be greater than or equal to 0. And then I'm just going to solve for x. When I divide by negative 1, I have to switch the sign. So x is less than or equal to 2. All right, these notes are going to go in your digital notebook. I already forgot which slides, 20 through 22. So here's slide 20, slide 21 for example 1, and then 2 and 3 on slide 22, and then go do your homework.